So let's have a look. We are looking at the rules for indices. So a to the power of m times a to the power of n equals a to the power of m plus n. So is that something you already know? Have you seen that before or not seen it before? Or? Some people have never seen that before. Some people have. So those that have, could you explain why?
Well, I haven't read it.
Oh, go on then.
Would you do like, so if it's like a squared.
So if we have a squared
Times a with 3.
A cubed.
Would you do a with 5 on it?
Yeah. So that's how we would use it. So a to the power of 3. So if I wanted to do that, simplify it to a single term, it would be a to the power of 5. 2 plus 3. Okay. The question is, why? Why can you do that? Anyone know? Thomas?
It's because a to the power of 2 it's the power of 2 plus the power of 2.
But why is the question? Yeah? Is it?
Is it like you can only do it when the base number is the same number? So since a is the same number.
Okay, but you're giving me a why, not why, when you can and when you can't, which is great. What I'm asking though, does anyone know why I am allowed to just add those powers? Why is a to the power of 2 multiplied by a to the power of 3 going to be a to the power of 2 plus 3, which makes the 5? Why can you do that? Or are you just accepting that's what I've been told?
But you can
Still
do it
equal, even if you had them apart. It's just easy to do.
It's just, but that's why I would want to. You're right, but why can I is the question. So if I just put numbers in, what is 3 to the power of 2 times 3 to the power of 4?
9 to the power of 6.
9 to the power of 6, you think?
No.
No, 3 to the power of 6.
3 to the power of 6.
Yes.
So who thinks 9 to the power of 6? Someone does, because someone said it. Nick, you think it was? Yeah?
Yeah,
Why would you... Okay, go on. You now think not. What would be your reason for now not thinking that way?
In the example, it says a to the power of 2 times a to the power of 3 plus a.
Okay, so we're kind of thinking it should be 3 to the power of 6. Okay.
Always keep the bases.
Okay, so we're keeping the base the same. So I think, as Izzy mentioned, this works if the base is the same. So that would suggest then, if I did 3 to the power of 2 times 5 to the power of 3.
Shut up. Well, people have to go to the cardboard.
So that would suggest that 3 to the power of 2 times 5 to the power of 3 is not what?
Not proper. 8. No.
not.
It's not
15 to the power of
15 to the power of 5, is it?
But it is.
Is it?
No.
Yeah.
No. No. Because if you do 15 to the power of 5,
I don't
you
know.
get the same thing as we did.
Well, I tell you what, just check that for me then.
I think it is.
You've got calculators. Just check for me those 3 different values separately. So we actually already know that 3 squared is 9. Do you know what 5 cubed is? 125. Do you know what 15 to the power of 5 is? You'll need to use your calculator for that one. Who's doing that for us? Jaden, do you know how to do it?
7.
There's a button on your calculator that looks like a roof. If you use that to raise to the power.
759.
Carrot? Yeah.
It's out right there. It's out.
75.
Yeah.
Wait, I want to see if I'm right. Am I right? What's the box? About how the same.
It's not.
It is a carrot.
Same as
The name of the symbol is not spelled carrot.
I know, it looks
Is
like
it a carrot?
It's a carrot. C-A-R-E-T.
I have no
In
idea.
English to like insert
Yeah.
a word.
It's not the
Yes.
carrot.
It's not a
But
carrot,
instead you
it's
put it on the
chalk.
bottom.
So anyway, we're going to use it by doing 15. I'm ignorant, so I call it my roofie symbol. And then a 5. And what answer do we get?
We
Thomas?
get
You gotta, oh, I just see it.
Oh, Mr. Thomas, you put.
I know how to say it, like, properly, because I'm really tired, but it's 759375.
7, 5.
700,059. Yeah.
Thousand?
759,375.
Good. 375. That's better. Okay. So my question is 9 times 125 759,375?
No.
No.
Wait, the top one?
This one had.
No, so what I'm asking you is 9 times 125 equal to that?
A
Yeah.
much smaller
No.
number. No, it's 1,125.
Do it. It's what?
1,125.
1,125. So I know that that does not. Notice the symbol I'm going to use for it. I can write a not equal to. Okay? So that would suggest that this cannot happen. So I think, as we were saying, if the bases are different, you can't just add the powers. Okay? So that's what Izzy said. Hakan said that as well. Like, if the bases are different, we can't add the powers. So again, I'm going back to my question of why can I then, if the bases are the same, why am I allowed to? Put your hand up.
Okay, because if you 3 to the power 2 times 3 to the power 4 is the same thing as 3 to the power 6, they just equal the same thing. But like,
All right, so how can I show that to someone? How can I prove it to someone?
you can put 3 times 3
Okay,
in brackets.
I'm just going to write over here. I hope I don't confuse you. So 3 squared is 3 times 3.
But put those in parentheses.
Okay,
It's like, then you do times,
times
and then bracket
3 to the power of 4, so that's
3 times 3 times 3 times 3.
okay.
Yeah, and then you just.
My question is, do I need the brackets? Do I need the
I'm
parentheses?
saying that because it has in the book.
Okay. Well, I'm asking you, do I need them?
Yes.
Why?
Because it's two different things. So if you take away any brackets, you might think it's like if you put a problem, then it's going to be. Like
So what are brackets for?
2, 3, 4, 5, 6. It's going to be
Because
every
it's-
6
But-
up to the power of 6.
Which
if you don't have
is-
the bracket. So if you put
But
the
isn't that what I
bracket-
said?
Yes,
It's
if you
equal
put
to.
the brackets to notify that that's 3 squared, and that's the 3 to the power of 4.
Okay. Thomas?
Bedmass, so you do brackets first.
Okay. So just list bedmass for me.
Brackets.
Exponents, division, multiplication, addition, subtraction.
So when would someone put brackets into an expression?
If they want to separate it.
And why would they need to put brackets around something if they want that?
That's the first part of like, you start here, this parentheses.
But if that bracket has a multiplication in it, isn't it going to get done kind of first anyway?
Yes.
So normally we would have brackets if we had to do an addition or subtraction first, and we don't in this case. So we
what
don't-
is the power of 6?
We don't. Exactly. So if we don't have our brackets, okay, if we get rid of those brackets, you can then see that,
What the answer is. You just like jamming them together.
yeah. So you cannot now tell the difference between 3 squared times 3 to the power of 4 and 3 to the power of 6 because it's all these multiplications. So if we think about it, it also is going to be the same thing as 3 times 3 to the power of 5. we've already done 3 squared, but we could also have 3 to the power of,
4.
well, we've got 3 to the power of 4, but 3 to the power of 3 times 3 to the power of 3. So it's like breaking those up. But the reason why we can do that is because we've got all the multiplications there. They're all listed one after the other. So it doesn't really matter when I do multiplications. They're all done and give the same thing, don't they? So that would lead us, hopefully then, we can then talk about what if I change it slightly and we have the rule which is if I did 3 to the power of 2 plus 3 to the power of 4, can we simplify that? What would it be if we can? So take note of my question. So can we simplify it?
Yeah.
Yes.
You think so? Okay.
Can you just get 3 squared and then add that to 3?
Yeah.
Okay, so you could evaluate it. Yeah? You could give it a value by working it all out. Okay. So you would say it's 9 plus 81, which is 90. But can I write it as 3 to the power of something? No. Do you see why?
Because that's what you do.
Well, if I wrote it out the same way I wrote these ones out, it would be 3 times 3 plus 3 times 3 times 3. And now, Thomas said BODMAS, however you want to pronounce it, what gets done first? The multiplication bits. I have to do the multiplication before I do the addition.
I know the same thing.
No, won't. So I can't rewrite that as 3 to the power of something because I've got an addition separating the multiplications. So even though the bases are the same, if they're added or subtracted, then I'm not going to be able to simplify. So it's only when we have our repeated multiplication. Okay. Do you see now why we are allowed to do that? Yeah? Okay. Let me ask you to have a think then about the division one. So the rule that you've also seen, that's in the textbook, is that a to the power of m divided by a to the power of n is?
A to the power of m plus n.
That would be the same as multiplying. Yeah. It's in the book, if you want to read it.
A to the power of m minus n.
Yeah, well done. So we subtract. So an example of that would be 5 to the power of 4 divided by 5 to the power of 2 is equal to 5 to the power of 2. So I would do 4 subtract 2 would be 5 to the power of 2. So I'm just going to ask you to think about that now. Again, why? Why does that happen? It's a hard one to think about, but go through the process that I went through in writing it out for. Yeah, so why subtraction? Why are we allowed to do that? So not just that's what it is. Try and think, and they'll probably explain it in your textbook. But have a moment to read through your notes and see whether you can explain in a couple of minutes. Okay, got it? Okay, so
A squared. Oh.
So let's have a look at one thing. So you're quite right in saying a to the power of 1 is just a divided by a. I thought I was helping you out by sticking with 1. All right, because I was then thinking, well, what you would do is do, well, it's a to the power of 1 subtract 1.
A to the power of 0.
Which is a to the power of 0.
I said that.
Which is
A.
1.
Well, A1. Oh, it's just 1.
Because what do you get if you divide something by itself? 1. So this is a proof that something to the power of 0 is always 1. Okay? Got that? Now, my question, I guess. How'd you get on? Sally finished in time, alright? Yeah.
If it was this, and then there was another
Yeah. Yes. That's us, really next. Okay. I'll put the video up, so if you need to finish off your notes, you can. So we'll be there if you're not quite finished. Make sure you have finished them off so you know for next time. Yeah. Homework, you give me homework. Okay. Okay, have a good rest of your day. Anyone else giving me homework? Cheers. You got homework for me, Daniel?
Oh, no.
Why not? Pardon? Because you haven't done it? You've not done it? Just give it up with that. Daniel?
Thank you.
See ya. Why not? Why haven't you done it? No reason. It's not, I didn't have enough time, or you just haven't bothered. Didn't even think to bother doing it. Am I speaking to parents tonight? Is that going to sound good?
Is there one in particular?
This one, thinner, taller one. It's next to some salad dressing on the door, yeah. Hello. How you doing?